So, in part 2 of Simply the Universe, we will be talking about dark matter and dark energy. Dark energy is the name given to the force that is believed to be making the universe larger. Distant galaxies appear to be moving away from us at high speeds, and the idea is that the universe is getting bigger and has been since the beginning of the universe, whenever or whatever that may have been. It is theorized to have taken up roughly 68% of the universe's total mass and energy, and of course, like anything with space, we are simply trying to answer the questions of the universe using what little we have to work with. And a prime example of dark energy would be the way galaxies and everything between our galaxy and beyond is slowly starting to disband and get further away from us as we speak. And this is where the Big Freeze theory comes into play. The idea that this expanse in the universe will become so great that things are just too far away to interact with one another. Stars would burn out and planets would be just too far away from any other stars, and galaxies would eventually die out. Now, I've panned out to make dark energy sound really bad, but it brings balance when I add dark matter to the equation. Now, dark matter takes up most of the mass of galaxies and galaxy clusters, and it's responsible for the way galaxies are organized on grand scales. It makes up to 27% of the universe's mass, and researchers use surveys to build maps of where dark matter could be in the universe, based on how the light from distant galaxies bends as it travels to us. So, quick comparison, dark matter pulls galaxies together, while dark energy pushes them apart. Now, considering the percentage difference, it's clear why we're expanding and not contracting, but if there was a universe where dark matter was in greater numbers, then the universe would experience the Great Crunch. Big Crunch theory is when the universe stops growing, it will actually begin to shrink. As the universe grows smaller, it will also get hotter, and one way to think of it is sort of the opposite of the Big Bang theory. Anyways, back to dark matter. Bear in mind that dark matter is a placeholder term for what it really is because it seems to be about 5 times more invisible than visible matter. So, what we mean by the name dark matter is that it has a gravitational effect like matter, hence the name matter, but we can't see it directly. It remains an unknown mystery to us, hence dark. Perhaps unknown heavy stuff would be a better name. But if we can't see it, how do we know it exists at all? It's like the old investigative joke. How do you know there was an invisible elephant in the fridge? Because there are footprints in the butter. Perfect example of this is the galaxy cluster called Abell 2218 that perfectly describes this. I'll revert the colours to black and white for a clearer visual on the way the image is warped due to the gravity lensing, also gravity lensing is what happens when something of an immense mass warps space-time. So light travels using space-time, and because of the mass it changes the way it travels around, so it causes this curvature on images. Anyways, you can actually use that technique to measure what regions in that image warp space-time and light, and how much. This is a prediction from general relativity, which somehow Einstein even made the equation used simply for a friend. I won't even try to describe the mass in this, because I don't really understand it at all myself, but it proves mathematically that by mass, gravity bends space-time. But that's the hardest part of the entire dark matter, dark energy theory. It's invisible because it doesn't absorb light. But if dark matter doesn't exist, what would universes really be like? Best answer I can give, it's probably going to be a whole lot emptier and darker, possibly without stars at all, and thus, dead, cold, and very empty. And we wouldn't be able to ask this question since we would likely not exist. And on that note, thank you for watching.